let's have a go at fixing this Intervolt 7 amp 24 to 12 volt DC switch mode voltage converter, or a reducer I suppose you could call it. Now I know this one doesn't work, but we'll go through how we're going to test that in a moment. A quick little rundown: it was in a industrial environment where it could likely have some moisture damage, also some vibration damage as well. But I think the likely culprit is that it's been connected to a load, I think, that is higher than it's rated. It's probably pulled more than 7 amps, and I'm hoping that inside we can find some sort of fuse or something that we can replace. Let's get into it. Okay, let's have a look at the fault of this thing. So if we turn on the power supply, and I'll set my output voltage here to 24 volts, which is the input voltage for this converter here. Let's just plug these in, like so, and set this to 24 volts DC. Perfect, 24.08 volts, like so. And there we go. Now we can expose the terminals, and you can see input and output, 24 volt positive, and we should expect a 12 volt DC output. The two 0 volt terminals in the middle, I'm not sure if they are a common negative, but we can find that out very easily. If we get our multimeter and put it on the continuity setting, we get perfect continuity there. Now let's apply voltage. What I'm going to do is just extend these screws out to give me something for my terminals, my probes to connect to. So, and then we're going to clip our test leads onto this. There's a negative. And positive. Now, this LED indicator at the top here, we should see a green flash coming on and off. Let's just give it a little bit more current. And what we don't have at all is a green flash, so let's just confirm our voltage is coming through. So 24 volts here, and we have no voltage output. So to get this apart, you basically have to take out the 4 screws at the end, and then this cover piece here will also come off. So we'll do that first. Let's get rid of these 4 screws. Once you've loosened off the 4 screws, you can take off the end cap. In my case, 2 of the screws didn't come out the bottom, but I'm not too worried so long as they're no longer contacting the aluminium chassis. And inside there you can see the PCB. To get this cover off the top, all we have to do is pry at the marked location, like so. That will come off. And then lastly, we can see that this cover here, you can sort of tell that it's a little bit loose, so to get that off we just need to remove 1 screw on this side. We'll do that now. And then this cover here can slide off. Now we're inside, let's just remove this terminal cover here. And you can see on the board there's a fuse just there, so let's test that fuse. And what do you know? We've got a blown fuse there, which is, as I thought, the culprit. A brief inspection of the board as well, you can see that it's very clean. There's no signs of any water damage or any sort of foreign particles that could have gone in there. So just as I thought, the load was too much for this converter, and it's blowing the fuse. So let's go ahead and remove that fuse and see if we can replace it. Now, unfortunately, I don't have a 7.5 amp fuse on hand. What I do have is a 5 amp fuse. Let's just test that that's okay. Yep, sounds good to me. So we'll replace that into there, and this will be able to confirm that the reducer is working. So with the fuse replaced, you can see that this LED here, this green LED is flashing, an indication that it's now powered again. And let's just check our voltage output. There we go, 13.5 volts. Perfect. And putting it back together was pretty much just the exact reversed order. Just make sure when you put it back together that this terminal label here sits underneath the lip here. And that's it. Lastly, our coupler can go back on. And there we go, fixed.